online meetup. And I'm Angela Kreitenweiss. I'm co-organizer and co-founder of TokenEngineering Berlin, and currently organizing a lot of other stuff related to token engineering. For example, the tech and the token engineering first hackathon track at Diffusion in Berlin last weekend. The token engineering community posted a couple of links to the chat. So there's the Twitter, there is a Telegram group, there is also a CatCat user group, and what else? Yeah, and of course the newsletter. So you can sign up to the newsletter via the Token Engineering Global Gathering website. So feel free to join and stay up to date on all our events and activities. Like this one tonight, we are going to discuss collaboration and cross-pollination between academia and practice. But before we start discussing this topic, I'd like to have a brief presentation of Ocean Protocol. Ocean Protocol is hosting us since more than a year, those meetups, and tonight, actually in Berlin, this is again the space and drinks and food from Ocean Protocol. And so maybe you say a few words.
Hi guys. Welcome to Ocean Protocol. We are very happy to host Token Engineering. For those who don't know Ocean Protocol, we are a decentralized protocol to enable buying and selling of data, basically unlocking the data for AI, and kind of enabling the ecosystem around data economy. What we have currently is version 1, basically where you can already buy, sell, publish, and consume the data with also prices. And we have also Commons Marketplace, which is basically a repository for open data. So public data itself, it's running at commons.oceanprotocol.com. Go check it out. And we were also the organizers, one of the organizers in Diffusion, and we also had some projects built on in Diffusion. And we also got some feedbacks in Diffusion that we need to make it more easy for the community to be able to build an Ocean Protocol. So currently we are working on those steps. So for example, a REST API that was missing in our protocol stack to allow user even not to understand the stack itself, because we have some components which they will need to understand now with the REST API, and they will be able to publish and consume and search for the protocol. Another cool thing that we are working on right now is tokenizing the data itself. So think data tokens, right, or data access tokens. So we are leveraging the current token standards, ERC20, ERC721, composable tokens, and basically providing the first-class support for those standards in our ecosystem, so that someone tomorrow, for example, can buy and sell the access to the data on outside of also the Ocean ecosystem, like for example OpenSea or wherever, or let's say tomorrow or in the near future you can also swap the data tokens with in Uniswap, right? So data tokens and swap with ERC20 tokens. So these are cool things which I hope the community will be able to hack on very soon. One other thing we are working on right now actively is version 2, which is competitive data. So this is especially for the private data. So as I said, version 1 is the public data, but for the private data, it's not very feasible to download and buy and sell the data. So what we are enabling is the compete service on the data itself for the private data. So yeah, these are the things we are working on, and I hope some of you will try Ocean Protocol and get on it.
If you are interested in building those things, we are hiring for 2 jobs, front-end and back-end developer. So yeah, berlinstartupjobs.com/ or message me on Telegram or Twitter at Ontology Machine. I can direct you to, berlinstartupjobs.com. So
okay, great. Thanks a lot. Thanks again for hosting us, and already looking forward to interesting concepts on tokenized data. Right? Okay, Now let's start with our discussion tonight. So we will have a great panel on collaboration and cross-pollination, academia and practice. And our guests tonight are Wassim Alsindi, Anish Mohammed, and in Vienna tonight, Michael Sorgen and Chris Farouk. And maybe you can say a few words about yourself, starting with Chris. Introduce yourself briefly.
Hi guys, how are you doing? I'm calling from Vienna, and Michael is actually visiting us, but he's sitting at the university and I'm already sitting at home, so we're not in the same room. I know Angela. We met around 6 months ago, or even longer. We were organizing the TAGG in August in Berlin together. So I am very happy that Angela invited me today because we had a very fruitful cooperation for the last few months. And I believe that what we came up with at the TokenEngineering Global Gathering was a very good selection of speakers. And my role in particular there was to curate the content for the scientific track. I am currently working at the Cryptoeconomics Research Lab, which is a research institution that is based at the Vienna University of Economics and Business. And our role there is to build the academic foundation for this new emerging field. So this is why my interest was in particular to find an appropriate selection of speakers that could contribute to giving a broad interdisciplinary perspective on token engineering in academia for the TokenEngineering Global Gathering. So I think that this is enough from my side. For now, I am happy to answer your questions then in the discussion.
Okay, cool. Thanks, Chris. Michael, would you be so kind to introduce yourself?
I'm Michael Zargum. I'm the founder of Block Science, and I am, in fact, in Vienna right now. I've been working with Sherman, who's the director of the Cryptoeconomics lab here, to write a research roadmap which lays out mostly a sort of unifying framework for the different terms around cryptoeconomics, and then to use that foundation to describe the forward-looking research roadmap, which actually ranges from purpose-driven tokens to data-driven economies, things like Ocean Protocol, and actually also the sort of ethical questions around steering platforms and what happens when we embed these kinds of decision-making algorithms into our social and economic infrastructure. I'm pretty excited about it. It touches on things from computational social science to cyber physical systems design and how they connect from their own disciplines into the emerging token engineering discipline, because, well, economics is a really interesting design space, and it's sort of one where we have both a sort of burden as engineers to sort of understand what we're designing, and also one that's very exciting as scientists to sort of explore together. So I'm open to discussions of both industry and academics. I have a PhD in systems engineering from the University of Pennsylvania, where I worked in the robotics lab and a bit with the Wharton team members in our group. So I have a pretty broad perspective, and I'm very excited to be collaborating with this community to kind of create a new field.
Cool. Thanks a lot, Michael. Akseli.
Michael, can I ask, you open to discussions of art also?
Oh, absolutely.
So what's the weird picture behind you?
Oh, so this is, I think, Bitcoin Rising, though. This is Sherman's office. I'm not familiar with it besides the fact that it's really cool. Yeah.
Yeah.
Wow.
Thank you so much for
That's the clap of that. The number goes up.
Akseli, would you take the next and introduce yourself?
Sure, yeah. So my name is Akseli Virtanen. I've been based in California for some time now. I'm from Finland originally, now back to Europe, and we are setting office here in Berlin. I'm a member of Economic Space Agency. I'm a political economist from my background. I did my PhD at the School of Economics in Helsinki, and we've been like working really on this. How would I put it? And what I want to talk about tonight too is the need for economic imagination, financial imagination. So That's
we will
it.
discuss this in this round tonight, definitely. Thank you for the moment. Wassim.
Yeah, so hi, my name is Wassim Alsindi. At the moment, I work with the MIT Digital Currency Initiative, and we're in the early stages of starting a journal and a conference series. We had the first event in that series a few weeks ago, so a bit later in the session, we're going to have a little recap on that. In terms of academia industry crossover, I'm 38, which means I've spent 20 years as an adult, and exactly half of that I've been inside the university, and exactly half of it I've been outside. So I've kind of been crisscrossing different fields, different modes of work, you know, from bootstrapping internet businesses to commercializing intellectual property in universities, working in a laser lab, organizing music festivals, and now I do this crypto economic stuff.
Cool. Thanks, Wassim and Anish. You.
Oh, my job. Okay. Hi, my name is Anish. I currently don't work with any academic groups. I worked in 3 crypto groups before. My background, I've done research in cryptanalysis. I've done other things. My first degree is medicine. I've worked across finance, bioinformatics, all the crap you normally say. Yeah, survive. I've done like a designer. We have probably half a dozen level protocols and like close to a dozen DApp. An Ocean happens to be one of them.
Okay, so I think first thing to see is we have already people who are well familiar to go beyond academia and collaborate with practitioners as well as scientists. And I think that's maybe one of some key attributes we see in the token engineering space as well, that we have a lot of people with who are able to talk with different people from different backgrounds, which seems to be a pro in our space.
It's critical.
It's critical.
You literally can't even have a conversation unless you have more than one traditional language. Yeah.
Yeah. And maybe
it's hard. It's hard. The dialogue is really hard also, but that's where the goal is made.
Yeah, and I think we will touch on that several times in this conversation. So I'd like to start with Chris. You already mentioned that we organized Token Engineering Global Gathering together in August. So there we had, our goal was to establish or to have another version of a global gathering in the token engineering space. And token engineering, the community, started as a community of people in the blockchain space. So blockchain project people who started to work on, at that time, white papers, develop concepts how a token economy could look like, how mechanisms could look like. And well, the perception was the more you work on it, the more you find out on the things you don't know. And so there was this great need of, okay, we need to know more. And of course, I mean, economics wasn't invented yesterday, so there seems to be a lot of stuff out there which we can use, how to connect those existing fields and token engineering. And so I met Chris, and since you're at the Cryptoeconomics Lab in Vienna, we discussed, okay, who to bring to the tag and what research is already existing out there. And maybe, Chris, you can give us a wrap up on, okay, what was the starting point and what you found out during the scouting process for tech?
Yeah, sure, definitely. So what we did, so I started with token engineering, I would say, roughly 1 year ago, where I met a big part of the community from Berlin as well, and also met Michael in person, because it was the Token Engineering Global Gathering, which was also hosted in Berlin 1 year ago. And this is where I got attracted to the field, and I realized that we need to proceed in an iterative manner. So we wanted to do, on the one hand, we wanted to do scientific research with regard to token engineering or crypto economics, but also we wanted to get insights from fields from the practice. So already 1 year ago, we realized that it will be very crucial for for us to combine whatever we see in practice and also whatever there is in academia. And so we started a token engineering meetup in Vienna as well. But after, I would say, 6 months or so, we've seen that it is very difficult to get everyone to the same table to talk about the same things, because many people, those who are in practice and those who are in academia, they have a very different understanding of what a crypto system is, what economics are, or how to approach this topic in general. So instead of trying to find out from people in which direction we should pursue our research, we wanted to bring out something from our side and make people and attract those who are interested in our approach. And this is why Sherman, Michael, and Jamshid, who are the associated researchers with our institute in Vienna, we realized that it will be very important to propose a research roadmap from our side. So instead of looking into the community, what people want us to do, we investigated what would be the best approach. With this in mind, we started to curate the contents for the TAGG as well. And this is why, from my perspective, we were looking for people who are who have a very firm understanding of economics, but also are very interdisciplinary already. So people who can handle complex systems and people who can handle different disciplines and are willing to incorporate them into their research. So in my selection of speakers, I always had this in mind. So who are the people who are interdisciplinary and who have enough understanding of their domain in order to help others to understand what they are researching? So for me, it was very crucial to have people with technical skills, people with economic skills, and people who understand the bigger picture and not try to focus on only one specific aspect of token engineering.
During the sketching process, I think every single week we had a call, and I was asking you, okay, did you now find a paper which relates to token engineering and token economies? And I think the result was there isn't any paper yet.
Exactly. So I was so in your conversation, in the conversations with you, Angela, I also realized that, I mean, it is very important to simplify or to make it understandable for the audience, which is very, very clear. But what we realized,
engineering audience, the practitioners audience, right?
Exactly. Because I've also been engaged with some real world projects, and I also see that it is very crucial for the people who are working on stuff. They really want to keep going, right? So they don't want to get lost in research. They want to have a clear direction in which they should proceed. So this is why I was very happy that you said, okay, you will focus on the practitioner side, and you let me focus on the research side, and I was able to really go deep into what different institutions, what different universities are focusing on, and so on and so on. And what I found out is that there is no one positioned out there who is focusing on the bigger picture. So there are many institutions, many universities, many professors. There is tons of material out there, and there are many people who are focusing on specific parts or specific perspectives on token engineering, but there is no one out there yet who is willing to tackle the whole monster. And this is why I believe that it is so very crucial that we in Vienna took one step back, and we tried to describe what complex systems engineering is, what crypto economic design is. So not talking about incentive mechanisms, not talking about game theory, but really talking about the crypto economic system as a whole, and having the necessity in seeing everything as is out there as a big picture. What we could do with the help of Michael, who also is in the call today, is we are heavily trying to incorporate engineering aspect into our economic design process. So Michael will talk about this at great length, I suppose. But what we wanted to make sure that is that people who are building these systems understand that we are creating infrastructure here for the Web3, and this is infrastructure that needs to be reliable, that needs to be predictable, and needs to be handled as if it was infrastructure that we are used from the real world as well, and that we need to include the full life cycle perspective of these things in order to make sure that we have the appropriate governance and we have the appropriate modeling and simulation incorporated in the design process.
Okay, thank you so much. We have a first question.
Yeah, hey, Chris, just one question. So what is it exactly that you mean with this whole picture, the entire picture? You mentioned a little bit about it, but like, would you like to elaborate? Like, what does it take to?
What I'm trying to say is that we have many things to consider, and the bigger picture would consist of the economy that you are trying to design, but also here understanding already that your economy is connected to the outside world. So you need to understand what the boundaries of what you are designing are, and how your economy interacts with, let's say, other crypto projects or projects in the real world, no matter whether they are digital or analog. So this is one thing that you need to consider. And the other thing that you need to consider as a bigger picture is that you need to understand that you are not building specific parts, but you are building a whole economy that consists of many systems that interact with each other. So your perspective needs to be focused on the outside of the economy that you're building, but also on the inside, realizing that the economy consists of several subsystems that are heavily interconnected. So the bigger picture means you also have to see which parts your economy consists of and how they interact with each other.
Okay, cool, Chris. This was, I think, a really good starting point for, okay, what is needed in academia to help the practitioner sector, but as well for new token economies or cryptic economies.
So what I wanted to hear was that you do understand that kind of that it's political, economy is political. That's what I wanted to hear. There's no big picture without politics. That's the.
Yeah, sure.
Avoid humans and the incentive mechanisms.
That's at the core.
But speaking of incentives, there's a couple of reasons I think that speaks to Chris's frustrations or the shortcomings that he sees. Mm-hmm. One of those being the kind of push versus pull. Yeah. Mm-hmm. That it's in industry, everything is structured incentive-wise for you to move fast, first to market, early mover advantage, break things, fix them on the way. Whereas academia,
governance is
whereas academia is structured historically completely opposite. To be very conservative.
More risk averse. That's how it is.
Yes,
in the industry, if you're a practitioner, you are actually being rewarded to take risk. Mm-hmm. In academia, it's the reverse. If you take risks, you're pretty much going to be paying the price for it. So this is like two different, two entirely different ecosystems who work in two entirely different ways. And how do you actually build a bridge between the two?
And the second part is speaking to Chris's point about why there weren't people doing token engineering in this kind of holistic bird's eye perspective, and the same with crypto economics, is that when you set out to do something radically interdisciplinary, it's basically non-career compatible with academics.
Absolutely.
With getting your professorship, with getting tenure through the United States. Think of all these different fields. Think of the different fields that crypto economics and cryptocurrency come from as mathematics and cryptography and protocol engineering, distributed systems, economics, policy, law, complex science, networks, and so on. So those is kind of like a ladder, and each ladder is full of a queue of people climbing their careers. And each of these ladders are very strenuously
opportunity, essentially.
Yes,
huge opportunity.
So jumping from ladder to ladder, or to make a link in between these two kind of parallel career tracks, you take a huge risk. This risk is disproportionate with
Return
the
on
gain
investment.
from staying in your lane.
Well, you're saying that there would be a time for something new.
That's good that you mentioned it, because there is the Crypto Economic Systems Summit, which took place the first time in October 5 to 6 at the MIT. So this is there. You want to have scientists there, so you are pushing research. But what's your goal? Can you please give us an overview?
Well, the goal of the summit, the Crypto Economic Systems Summit, was to kick off the whole program of activities with the journal and the conference. The idea being that set out as we need to go on, which is to kind of build this big tent where we can bring academics and practitioners, people from different disciplines, and people with let's say interdisciplinary perspectives, horizons, and desires, and just to try and kind of collectively leverage their wisdom and their experience and hash it out, and to discuss the pain points in research, pain points in collaborating between academia and industry, pain points in publishing and disseminating work, and all the rest of it. And on the whole, the response was very positive. So we took a lot of heart from that. And it's also helped us try to understand how we need to iterate as well. Nothing is born out of a vacuum, perfectly and fully formed. So we're still trying to figure out, which parts of the kind of scholarly publishing machine are should we try to re-engineer? Which parts of it look like they function well enough that we can roll with them? So think about this, for example. In computer science, the field moves very quickly. And so it's very rare that a journal will be the ultimate port of call for an impactful, timely piece of work. You'd rather get into a conference so it's disseminated quickly, and then that gets published afterwards as proceedings. But then you compare that to how law works, where all the legal journals are run by students.
Yeah.
So then the kind of gravitas of publishing in law review is completely different than publishing in a crypto conference and proceedings. In economics, you basically have to publish in one of half a dozen monolithic, gigantic journals that's existed for 100 years if you want to be a professor in with tenure in a US university. So these things are not career compatible among each other, between each other. So to build something interdisciplinary that connects to all of these things is a tremendous challenge. And that's, if you can help me, then please get in touch.
Okay, we'll try. So even within the academic sector, looking at the disciplines required for new cryptoeconomics, we have already very different speeds, for example, or different incentives. Now, of course, the practitioners is again a totally different challenge. So now, Michael, are you still there? Michael Sargam.
I'm here.
There you go. You have a very good overview on the practitioner sector, on how blockchain projects work. You have been working together with a range of different projects, helping them to set up, structure their token concept. So can you give us a picture of the state of the art in the blockchain sector when it comes to cryptoeconomics and token economies?
Sure. Before I dive into it, I want to make one quick comment about the whole sort of politics point. I think it's actually super important that people keep the sort of the layer of decision making and why people make decisions and how they make decisions as part of their economic context. It's part of the reason why I said unifying when I first talked about my introduction, and how that relates to the implementations with respect to industry work. It's very often that we have to put a lot of effort into extracting what people are trying to accomplish and why. These are sort of like requirements in an engineering context. Like, what is it that you hope to accomplish? Not what are you building, and not like how are you building it, but like why are you building it? And taking time to figure out what the goals are is necessary for the actual sort of stages of development, because you want to do token engineering as a sort of design process, but a design process itself, while it generates requirements for implementation, it comes from requirements that are the founder or the community or the project's goals, and those goals actually encode some belief system, they encode some politics, they can encode a lot of things. And so we see often a lot of lack of clarity in that level, and then we have to work with people to encode those in a set of design requirements, and then use the design requirements to help derive algorithms or incentives, and then use simulation methods to sort of test those designs against the potential uncertainties. So there are lots of uncertainties in economic systems and in complex systems in general, but in particular, anything that involves people. And the thing that seems to be true of economics, at least in my experience of studying it, is that most of the lines between fields are drawn on the basis of assumptions. So a particular branch will make certain assumptions about how to view the world, and then their conclusions will come in a large part as a consequence of those assumptions. But the assumptions are actually not the things that we know. So in an engineering context, we actually do a lot of what Shebnam would call version controlling your assumptions, where you've made a design and you say, if I assume this, what happens? If I assume that, what happens? And actually do a battery of tests where you evaluate against a variety of assumptions as a way of sort of understanding what might happen, which is distinct from making a prediction. So it's not predictive analysis, it's risk mitigation, it's asking whether requirements are met, it's asking whether the algorithms that you're putting in place are upholding the values that you laid out in that sort of design. It's a variety of sort of process, but also sort of methodological tools from engineering, but not engineering in the software engineering sense, engineering in the sort of civil engineering sense, where you're building some public good or some public infrastructure, and you want to make sure that it is actually meeting the needs of the public it serves, and that it's safe for them to use it, and that it's adequately maintained. So Chris alluded to full life cycle. In the context of crypto networks, I view governance as a form of adaptive maintenance. You can't launch something and just hope that it fulfills your needs and hope that it will continue to fulfill the needs of the community that it was launched for. You have to have an understanding of the interplay between the evolution of the social system and the potential need for the evolution of the technical system. So I think my sort of summary is that in practice, there's a need for a richer theory than is currently used in the sort of startup mentality, but that we need to, as a community, find a way to make that rich theory into a form of best practices so that we can keep the sort of pace that the industry needs, because otherwise it'll just ignore these things. So these questions won't get asked and answered if we don't provide a sort of way of knowing what to ask, knowing how to approach answering it, because if it's unclear, it'll just get left behind.
Yeah. So you say we need to make this knowledge and methods more accessible. So maybe this also refers to CAD-CAD.
Yes, so CAD-CAD is the complex adaptive dynamics computer-aided design Python package that the block science team developed. It was mapped out largely to facilitate these workflows as we were writing sort of bespoke simulations to test designs with clients, and it was very time consuming, slowing down the process. We were working in the Python data science sort of toolkit, and we decided to introduce a sort of dynamical system, sort of business logic for both the economic protocol and incentive layer concepts and models and assumptions about human decision making in a sort of framework that unified the agent-based modeling literature, so you can always represent individual agents, with the sort of system dynamics literature where you can address the adaptation of system scale properties so that we can look at how those things interact. I'm pretty proud of it. We've got a lot of work to go, though, to line up sort of best practices for using it. And I'm sort of enthusiastic about the degree to which the community has started adopting it and providing feedback on best practices for this kind of design and testing.
Here's an interesting question for you, Michael. So CAD-CAD is like not a million miles away from something that could have been developed in an academic lab. But
already exists. There are a whole bunch of them.
Sure, but like what happens to so let's workshop it for a moment here. Indulge me. So let's say a PhD student is working on, a postdoc is working on this, and then they all have their own versions of code. They all have their own versions of code, and they're not, they're not compatible. And then working, let's say a rough copy is passed around the lab. Maybe it gets passed from group to group to other researchers in other universities. Then that PhD student finishes their PhD. Unsupported, dies out. Okay. So then this is, I think, one of the other reasons why it's interesting to compare something like what block science is Zargham is doing with block science and CAD-CAD with all the countless pieces of now broken. Like there's a software graveyard in academia, like of things that were useful at a moment and they could be useful now, but there isn't the resources or the environment to maintain them.
But I would probably counter this as well. So it's like, if you look at the Linux ecosystem, you can actually see some of the people who wrote a bunch of drivers and things like that got adopted. Okay? The difference is the adoption, right? If somebody turns up and if somebody really finds it useful, a bunch of them will volunteer their time to actually, contribute to it, take ownership to it, and continue to develop it.
So
and
two
that's
things.
the decision that needs to happen.
Two things here. One of them is that, at least in my history in academia, the vast majority of the things that we do in CAD were done in MATLAB. And MATLAB is a very expensive paywall software that's used by electrical engineers, control systems engineers, and people working on mathematically intense algorithms problems where, if they're going to be deployed into real systems, they tend to end up going through sort of either completely separate implementations in a low-level language or using some sort of compiling equipment to bring it down to something that could be implemented on board on, say, a robot. I worked on a robotics project, did navigation systems in MATLAB, and then another team member wrote sort of C code that went on board. So there's a little bit of a jump here because the class of things that we're working on doesn't necessarily get done in an open source software environment. The extent to which it does appear to be happening in Python. And so part of the nice bridge here is that by going into the Python ecosystem, there are network scientists using NetworkX, there are machine learning researchers using TensorFlow or scikit-learn, and these things are accessible in the Python environment. So the adoption dynamics here is a little different because we're getting into and unifying with a bunch of things that are used in a cross-disciplinary way. And so it also lowers the barrier for us. We could focus on doing a really good job with how we represent these adaptive dynamics and not have to basically write mediocre everything. We could write one thing really well and use other people's work that's also done really well.
Yes, but Ben, to follow up from that as well, I agree with you completely. Follow up on that as well. Something like CAD, it's basically been developed with the widest possible utility in mind. Whereas something that comes out of a university lab, it may just be, with the requirements of that particular student and their immediate vicinity in mind. So that may also speak to why things get adopted or don't get adopted and fall into the graveyard or make it happen.
What's interesting, Wassim, though, is that CAD was developed based on work that did start as a ICSS paper, ICCS, International Conference on Complex Systems Conference, where I was speaking about these sort of networked dynamical systems with adaptive elements in the context of blockchain economies. And I had done quite a bit of work to make a mapping to state space dynamics, and found that, like, in order to actually proceed, I needed to, basically build that sort of state space representation into something Pythonic. And obviously that's a bias that we were using Python already, but there was also an academic lineage in the sense that it started with a conference paper.
And I think, by the way, if you wonder what CAD is all about, so I will post and publish the links to this tool and also to the open source user group for CAD in Twitter. So it's TokenEngineering, and you can take a look. But what I also observed is that, this is not about is CAD wrong or right. So you already tried to explain the benefits of it. But I noticed that in our community, with people from a range of different backgrounds, such a tool is really helpful to come to a similar layer to discuss token economies. So to structure the design of a token economy and to come into applying your ideas or structure your ideas and then come to simulations and have let's say a common tool which creates a common language and then helps to collaborate. So this was also for me very interesting to observe.
So I want to tee up Exceli a bit, because one thing that I think is really important about computational methods is the ability to explore a design space. So you have this new design space and we don't really understand it. We have not explored it. And we want to be able to avoid falling into the traps of just building all of the things that we've seen before in the world. And without the power of a computational thought experiment, we can't really test ideas that represent things that haven't happened in the past. And this is a rare opportunity for us to sort of think and explore beyond what we've seen before in the economic paradigms.
But not only that, it's also providing, being like a framework of knowledge in a general sense, it also provides a way that you can produce results that can be compared and contrasted. And you provide
thought experiments.
It provides you with like quantitative aspects of grammar or a visual aspect of grammar. And that's a little bit like what I was trying to do with token space as well, right? Try to find new ways that we can describe things, because like small mouth noises that we use normally, it's tough to communicate nuanced and complex topics.
Okay. Now, we've taken a look at the scientific area, at the practitioners area with CAD-CAM. So I'd like to ask you, Anish, what do you think, what could be a good setup for collaboration between academia and practice in cryptoeconomics?
That's a good question. I honestly don't know. This is a tricky thing. Like, the opportunity cost for anybody who's a practitioner is really good, be quite high. And on the other side of the equation, if you're an academic, if you're really good, okay, I'll take the crypto space. Like, I know crypto space, I was in a bunch of crypto groups. If you're like an exceptionally good cryptographer in a, say, algebraic number theory, ellipticals and shit like that, you are unlikely to step in a blockchain, because like everybody else around you will look at you and laugh at you. There are, no, I'm not kidding. I know Palash and the rest of the guys, and I had a conversation once.
Look at the conversation around David Cham.
Yeah, absolutely. It's simple. Like, David Cham just stepped out from the academic crypto, not the academic crypto world into blockchains.
Not even blockchains, it's close enough.
So it's like there is this, opportunity, not an opportunity, social cost accrued by stepping into this space. So we need to find a way by which, practitioners, because like one of the things I think is missing in this whole conversation so far is that, there's a whole bunch of academic stroke practitioner expertise in the financial engineering space, which is actually being heavily borrowed in the token engineering space by market makers and people who play the so-called exchange game, which is a traditional game on the other side of the bridge. So that is like a well-bound, well-understood, a lot of Python shit. Okay, sorry, Python code. Right? Okay, a lot of frameworks that we use, NumPy, SkipPy, all those things all came from the other side of the fence. So that's actually happening. So there are lessons learned from that bunch as well. So it's like, if you look at dark pools and you look at what happened in the space, literally that's happening on our exchanges, front running is happening. So all these things are happening. How could you actually get a bunch of people who actually have like massive opportunity costs to collaborate on something and come up with a result that's acceptable to normal people? I honestly don't know. Maybe it is that academic institutions could allow practitioners to come in and work with them for a short period of time, work on a particular thing and walk away, because like they might be able to afford a short period in time. And similarly the other way around, like that's what Facebooks and the Microsofts of the world do. They get professors to come in and just do like a sabbatical for 2 months, 3 months. Maybe this is one way to do this. So like
the pull is strong at the moment, so people go from academia to industry. The Professor Coinexit, this is a real thing.
To do what?
They don't come to
what?
Well, it depends on the circumstance.
Oh, I mean, look at machine learning space. Look at machine learning space. Look at all the CMUs who lost a whole bunch of people. Whole the robotics team pretty much like disappear like that. It's autonomous, space. So it's like, it applies to different places. It's like, what is the opportunity cost for doing? What's the opportunity cost per unit person of expertise per year kind of thing? Is a question you have. Say, for example, if I'm not mistaken, Sebastian put his finger in the air, put the autonomous vehicle navigation, right? That's a pretty high mark. I'm not saying that's the, so that opportunity cost implies that, if that's there, and if you make like a X amount of money, that's 2 orders of magnitude less than that.
Okay, so let me put it this way. So my problems are different.
Yeah.
Like my friends in academia, best professors in I think in finance, political economy, like and feminist economics, and heterodox economics, like they why should they come? Like, why?
Good question.
Why?
You should be from
like this the
to blockchain or to
yes, like to why? And we are struggling in answering this. Trying to kind of, from my perspective, they they're kind of missing the opportunity which is built into it, but it has to do with that. I mean, this is more than just like about disintermediation or something making money, but it's about like a new social form, new form of relationality which can be born, and this like our group, for our team, we are struggling to articulate, like get across.
There's this quote that I'm gonna butcher it, but I'll get close. It's from Antoine de Saint-Exupéry, which is, if you want to fill your boat for a voyage, don't teach the men how to row and swim, but instead make them yearn for the vast and endless expanse of the sea.
Yeah.
So it's it's the why, the motivation, the magic, which like we have trouble communicating. Some of us find it by ourselves.
I'm
so Anish, can I speak to this for a second? Because there are a few projects that I'm aware of that are working on social credibility and reputation systems, as well as if you guys have heard of Moloch, it's basically a decentralized funding system, but how it works is participants or different engineers who are working to build on kind of a public good project is the idea.
Is that what you're talking about? I mean, we are not talking how much Moloch. I mean, I've been on the call. I mean, Amin was actually describing what has been done. Forgive me for saying this. It's like it's not the most sophisticated thing to be done. The challenge we are questioning is like, what are the hard problems? Are we willing to take those hard problems head on, right? That is not including like 10 people or 50 people. Moloch DAO unlikely to scale to a degree that we actually want to do.
It's a signaling mechanism.
Yeah, absolutely, yes. 100% agree, signal mechanism, okay? But beyond that, I am really struggling to see real efforts coming in. Like, call me a cynic and a skeptic.
But maybe let's not stick with Moloch DAO. Nevertheless, thanks for raising a question. But just back to you, Chris. What about the why? So obviously, you founded the Cryptoeconomics Research Lab. You are setting up a research agenda. What is the why from your perspective?
You mean why we should engage in this as a researchers, right?
Exactly.
Because I can give you a very simple answer to this. So my answer is because cryptoeconomics is economics on steroids. So you can actually make things that you've been analyzing for 250 years, and you can see how they will evolve and how changes in policies or how changes in design will influence the outcome. So what we are trying to convince our fellow researchers about is that they have a playground, a very attractive playground where they can put their ideas into place. And once we get them hooked, and once they understand that they can start building digital economies where they can play around with it, and where they can start analyzing what their changes, how they will affect them, and now we got them interested. So this is the reason why we should, why we as researchers should do it. This is the one answer from the curiosity standpoint, I would say. But from the responsibility standpoint, you also could argue that it is our duty to make sure that the things that are being built right now are built with some ideas. So built in a sense that they are being built responsible. And many people will start relying on these decentralized ecosystems. They will be using them. This infrastructure is really system critical infrastructure. And also many people are heavily invested in these digital economies already. So as scientists, as researchers, it is our responsibility to make sure that these things are being built in a reasonable way.
Axel, do you want to add?
Yeah, I would like to just elaborate on that. I think it's a really good comment in the sense that it definitely opens what is important. That what's happening is that we really do have this laboratory opening up, this place for experimentation. But I would really, that's absolutely, this we also see definitely there. But I would not hope that we try to like put on steroids the kind of conservative and orthodox economics that has led us into the catastrophe where we are right now, but rather think that maybe we can what the kind of the informational networks empowered by the cryptographics, it in fact opens new framings for economy. We can start to experiment with different valuations, different ways, and this is what excites me.
Yeah. Can I add something? It's like, if I were allowed to say this, it's like I consider most of the financial engineering as being information arbitrage.
Absolutely.
Okay.
Absolutely.
And the way I think about absolutely true information arbitrage. So if you have volatility, like plain, right? So to me, the thing is like cryptography as such actually has a lot of tools that could reduce this information asymmetry to very tight bounds. So it is very possible that we might be able to run some of these experiments, which in the real world is incredibly orders of magnitude more expensive, right? And we could actually test this in the real world. And this is something I'm like, one of the things I'm really passionate about, because I see we as humanity, we have limited, bounded amount of resources, time, and other things, right? If we have like a bunch of problems in front of us, like the list of problems we normally call the existential challenges, right? If we were to take any one of them, maybe
ecology,
all of them, like take any of them, right? Take any, randomly pick any, the one like you like the most, right? And if you want to get to where you want to get to, you want to run so many experiments to get to a steady state that you know you can survive. And to me, I see this as a very tangible, possible, one of the many, okay? Very tangible, possible ways by which we could run a whole bunch of experiments, find optimal solution sets, okay? And that's the way I see it.
Okay, so that means cryptoeconomics open us the opportunity to test new economic setups before we launch it to the
Absolutely.
Well, let's reformulate a little bit. Okay. Optimization, sure, we can think about that too, but let's say, sure, what? Let's say that we can use the grammar of finance, for instance, which is great. It's about let's recap a little bit.
Are you having this how could I say, the challenge between the logical beings and illogical beings? The way I think about it is, to a larger degree, we have the challenge of more and more logical entities entering the space and being economic actors, and them having a larger effect. That's the way I think about it.
Yeah, I think a little bit different.
Okay, sure.
I think that we can also, in fact, abstract the grammar.
Yeah.
And start to index, to use the grammar to express a little bit more things.
Yeah, sure.
In a different way.
Yeah.
In a different way, that we can start to not optimize only towards the one thing, the possibility, but maybe some other things, maybe let's say environment.
Another huge problem with being focused on optimization is that you can easily optimize yourself into a local minimum.
You want to have a global one, and you want to understand multidimensional. It's
sure.
I mean, if you're optimizing on a plane and you look at a curve, it could be a curve in a different shape, and you're on a different plane, it would be a different shape. So, I mean, I fully agree. I mean, I've talked about it before, but the way I think about it is like, going forward, one of the things that I think is interesting and more important for all of us who are interested in the space is we have this biggest challenge of having humans, the illogical actors, as being the key players. And one of the things I foresee happening in a much more recent...
Did I hear you say humans are logical players?
Illogical players. Illogical players, right?
Yeah.
So it's like, I see more and more logical actors entering the space. It's like, if you were to have various things.
Scary. So you're talking about autonomous agents?
Yes, possibly, yes. And that
unless you're going to find some rational
rational humans or some of the planet. Rational beings on the planet. Yeah.
Really?
Yeah. Absolutely.
That's fucking scary.
Yeah, that's what I'm saying. It's like we probably have an opportunity to think about this slightly differently and think forward and see what's the best strategy to have. I mean, imagine a situation where that's bigger than the current set of actors.
Okay. Maybe we can have a short break here and touch on all these autonomous agents in the next part of this discussion. I now want to open it up to the audience. Are there any questions on that at the moment? From remote participants also here in this space?
Hi, Anish. Oh, hello.
Questions?
One here.
Yeah.
What do you think about the development in Nicosia from the university there?
Okay, the question was, I repeated if it was too silent. Question on Nicosia University, an opinion. Anyone up for, do you know this university?
Yeah, they've had the Masters in Digital Currency for quite some number of years. I believe some of our friends have been on that course. I don't know that much about the syllabus in detail myself, so I won't pass comment on that. There is a general trend in academia there's a race going on. A race towards people cooking up new courses, digital currency courses, blockchain courses, fintech courses, and this is like we're going to maybe sidestep into one of the structural problems with academia here, which is the marketization of higher education, where the traditional way of these things getting funded with state money or wealthy benefactors or public sector purses of different kinds, that's kind of drying up. And so a lot of people are looking for, to run courses, and faculties in these institutions are looking for ways to fund these things. So one of the ways is you set up a money spinner course with one or more buzzwords in the title. I'm not saying that this particular course we're talking about in Nicosia is like this. I don't know anything about it. I'm just talking about a wider trend here. And I am a recipient of a master's in financial technology from a university that did exactly this thing. So I've seen it firsthand.
Yeah, I'll put my hand up. Last week I taught in 2 very reputed universities, and my observation there was like the motivation on the student side and what the academia was actually providing probably doesn't intersect that well, because
it's bad.
It's like signaling hasn't really been in the appropriate.
In the few universities where there are genuine subject matter specialists or people with deep and broad knowledge, they can do quite good courses. So a few of my colleagues at MIT have delivered pretty good courses. You can see them on MIT OpenCourseWare if you so choose. There's a technical course on cryptocurrency engineering. There's a blockchain ethics course going on at the moment. And they're both very high quality. But I've also attended courses that were clearly put together by people that had just copied stuff off Wikipedia in the minutes before they went up to speak. And then they would just say completely wrong things, and then when you correct them, they would throw you out the room. So there's a structural problem with the university teaching side.
There's also an inverse problem associated with what people want to take versus what they can and should take. I'm going to sort of zoom back in time a little bit, but I was teaching convex optimization and dynamic optimization at the University of Pennsylvania, which is a graduate level, basically applied math class, at the same time that most of the students were also taking machine learning, and that's a great course as well. But one thing that I realized quickly was that people are very, very disinterested in understanding how or why the algorithms that they used embedded mathematical assumptions that could, say, reproduce biases, or the way in which their choices about sort of, say, machine learning model or technique would affect the way that their results sort of captured or didn't capture biases or things that were embedded in the data. And the way that you learn this is by learning how to derive those algorithms, where they come from, where the mathematical machinery, the way that it works. And what I found really a little bit disappointing was that about 80% of the class basically was like, we don't need to know this because we have these algorithms and I can import whatever. And what that made me realize is that at some level, the education that's being provided exists not to give you what you want, but what you need. And while this is a little bit closer to the sort of data science and machine learning arc that was, some years ago, the buzzwords, I am worried that we see some of the same thing with some of the sort of blockchain and fintech stuff, where people are getting what they want rather than what they need.
Higher return on investment for the time you can spend. That's the simplest way to optimize it, right?
Look, the way I heard somebody put it a bit more bluntly. It's like people take the algorithms courses because that's how you get a job at Google as a software engineer. You need to take the algorithms course. And so there were a bunch of people asking in the blockchain space, why doesn't anybody know anything about cryptography? Why is nobody taking a crypto class?
Okay, so let's just add there. It's the same thing about the economies. No?
No surprise.
But
So what you need to
Michael.
practice responsibly is not the same as what you want to take. So using the AI example, if you actually paid attention to how the algorithms that you're using work, then you can apply them more responsibly. It is not that hard to understand when things encode and maintain certain biases, but most people actually never learn how they work well enough to understand the ramifications of the implicit assumptions. And I think that this is a place where the academic industry overlap is really needing some attention, is what do you need to know versus what do you want to know to get a better job?
Yeah.
there was a
And the same
question.
thing about economy. That's just
But this requires people inside these organizations to be motivated and to have the desire, the will, and the resources to take a step back and not just move around the hamster wheel. The hamster wheel of the university is find more funding to keep the faculty alive. The industry is get to market first so that we can
Make more money.
monopolize.
Yeah.
Now, maybe it would be interesting for the audience to, what would be your recommendation if you want to become a token engineer? Where to go to learn what you need to know?
I would suggest, well, I'm coming from an economics perspective, and a lot of what Michael said resonates with my university experience and what I'm learning in my classes is we've been taught to basically, take a lot of the economic assumptions from neoclassical school and the different schools of thought, and we've been taught to kind of take that as being reality and being factual, which is really a limiting and horrible way to teach economics, because
Actually, every branch of education is like that. So I studied chemistry and physics, and before you do your first Copenhagen interpretation, quantum mechanical calculation, you have a list of approximations as long as your arm before you begin.
the economics is a little different. It's social science. In other social science, it's a debate. There's no.
What is reality is a debate, right? Yeah, so it's good.
Also with quantum physics.
But any other recommendations?
So that's a complex issue, but I suggest anyone who's looking to beat those assumptions and go beyond that and actually discover and observe for themselves how the real world works, I would say look at systems, dynamics, and complex systems. And that's kind of how I've arrived at block science's work. But I've been focusing on post-Keynesian economics for a while now and looking at, nonlinear modeling and how we can really engineer our way toward getting a broader conception of how these systems work and bringing in bringing in kind of randomness and all kind of embracing the complexity of the system. That is what I believe will get you out of that kind of limiting mindset that a lot of academia is kind of known for pushing onto its students. So
could we ask this obvious question? Like, what would be the bloody criteria for becoming a so-called token engineer, right? How do you measure it in a practical world? Is it like do you do a real design for something that other people attack and break it to pieces? I mean, if that's the criteria, I mean, there would be no token engineer standing because like all the market makers do them, okay? So, I mean, to me, it's like, okay, if you are from a crypto world, the way crypto world works is you design a protocol, you give it to peer review, and like all your buddies kick it first, right? Yeah. If it's kicked completely, you don't even submit it anywhere. It dies then, right? What seems to be missing in this ecosystem is like, that level of skepticism is missing. Like we have like, if you were to develop a crypto algorithm, what happens is like it goes through a whole bunch of things. And then when the standardization happens, you provide the libraries and you provide the test vectors, and every monkey on earth should be able to do that. That's what it is. It's like we don't expect anybody who uses crypto to understand elliptic curves, algebraic number theory, nothing. Okay, we understand you to understand some basic concept. Absolutely, tightly bounded, clear and precise, very clear and precise. Because it's a very Boolean thing. Yeah. You encrypt, decrypt. If it doesn't work for a single bit, it's done.
You're talking about.
Yeah, sorry.
You're talking about the low-level sort of mechanism design problems that are implicit in protocols. And I don't disagree that that's essentially an existing field. But what happens is that becomes the kernel of a social system that has elements that are both unfalsifiable and also unpredictable, and they're not a question of right or wrong per se. Even they're just a question of what kind of trajectories emerge. It's a can happen, not will happen scenario. But it's the difference between this sort of micro layer where you're doing the sort of cryptographic mechanism design, at which point you can assert that certain things must happen, and you can assert that certain things work in a certain way, but they're only the sort of low dimensional kernel of a higher dimensional social system space, and we can't assert things about that layer of the system. We can only sort of have the mathematics of things like configuration spaces, reachable spaces, the can happens, not the will happens. And so there's a boundary there where I think we go from the sort of cryptographic mechanism design base of designing protocols, and then we have to ask a different set of questions about the sort of economic and social systems that then sort of are enabled by the existence of those cryptographic protocols. And so there's a split here which requires different methods.
This part needs to be done before you do the rest, right? You don't even have, my challenge is like, when I look at these protocols, if you can't really provide the basics, there is no way that you're going to provide extras, right? So, if you were thinking of the Maslow's hierarchy of needs, the way I think about it is like, what you're talking about is like higher up there.
Yeah.
And I don't think I'm anywhere near that. I'm a guy who's coming up from the bottom up. And I'm looking at somewhere, middle of the path where I think, things can work. Even the boundary conditions that you could actually make these things to work, even that is not known. For your conditions to really reach there, you need to have very, clearly defined, efficiency boundaries.
But it's bidirectional, because at some point, if you're designing at the level that I was just talking about, you're deciding what kind of properties, what requirements your protocols have. And obviously there's an interrelation here. You impose requirements, but if you can't meet them, then you have a change above. But you're talking about multi-scale systems, which is like a robotics problem where you have a layer, which is a mechanical system. You can't make it work by violating the rules of physics, but the system a level above it is an entirely different character. They're mutually constraining. So if you state the problem that you need to solve at the cryptographic protocol level and you can't solve it, then maybe you have to iterate back to, hey, maybe those aren't the requirements after all. But I think there's an important hierarchical distinction here between the cryptographic mechanism design problem and something that's a little bit more open-ended.
Okay, we have a question.
Yeah, because it seems to be like the discussion, like whether if you want to study chemistry and you have a chemist prep, you first have to study physics and then maybe the physics of the atoms and below, or maybe you want to go biology, so you have like this whole hierarchy. So I think this was part of your argument up there, that you first have to do the cryptography, which would be like the physics, and before you can do chemistry. But this is not the case. You can already do chemistry, assuming that somebody set up actually the chemistry in such a way that it's compatible with physics. So yeah, and
yeah.
Actually, I have a really nice diagram for you.
Moment, what's your comment?
No, if it is there one class of token engineers, or does it need to be a team effort maybe, and not everybody covers all the aspects?
It can be a spectrum.
Yeah.
A spectrum. So the reason I just want to mention to you, if you look up this phrase, the ontological metastack, I actually have a diagram which connects from natural philosophy to mathematics, physics, chemistry, life sciences, social sciences, and other complex domains. The idea being that you don't need to exist at every level of the stack, but the wider scope you can have on those disciplines, the better informed you might be of the emerging characteristics as you go higher up, or the atomistic mechanisms as you go down.
Okay.
And I wanted to answer his question about the expertise. My experience and with my team, which has people with controls backgrounds, economics backgrounds, data science, we've really decided or found that the token engineering that we do, at least, is much closer to a systems engineering, or like a sort of architecture, or a sort of high-level systems engineering, where you need to have enough expertise about each of the subsystems to interact with the experts of those subsystems. So you certainly need to be in a position to kick someone's crypto, as Anish would say, but you're not necessarily a cryptographic mechanism design expert. You also need to have enough understanding of this sort of computational social science and agent-based modeling to explore whether certain incentive rules actually relate to the goals stated by the people, and so on and so forth across a wide range of topics. So it's a little bit less like expert in one thing and more about lateral or horizontal expert whose job is to help tie together a very interdisciplinary field. And that's just my perspective, but that's what we found success with, not necessarily trying to be the de facto expert on one layer in the ontological stack, as Wassim would say it.
Here's a challenge though. Like we know, like academia and traditional education systems are structured towards a convergent hyper-specialization. You become the master of this one tiny thing. That's kind of
PhD thesis is
the end of it. Your PhD thesis, you're the world expert in the one tiny thing. So how do we then like invert this and train a new generation of generalists? Basically talking about training generalists here. So how do we do that? Because the existing structures we have don't seem to lend themselves well to that.
I mean, I'll probably put my hand up and say this. Like, generally speaking, if you had to apply for a cross-disciplinary PhD, so I will put my hand up and say this. The academic institution, including MIT, putting it out very clearly, MIT is the most open one, okay? They are willing to talk to you. But most people are shit scared of people coming totally outside the domain, right? Unless we are, because they're thinking, okay, why should we take the risk of reputational risk, capital risk, all the other resource risk? So we need to actually find a way by which we can, allocate a bunch of resources and say, this is the risk that we are willing to take, and allow people who are crazy. I'm sorry,
But that's more like you take a bunch of single discipline specialists and you stitch them together into a multidisciplinary project, rather than having an ensemble of generalists. And by the way, there's a great formal term for what you're describing here. It's a paper by Valentine, I think it's in Mind. And it's called epistemic trespassing. People that just go into different fields.
We don't need I don't think the university is the place where these things are actually happening right now. If I think of our team, for instance, economic space agent, that's like explicitly what we are trying to do. It's like the Xerox Park, the Bell's Lab, where they explicitly try to bring like people from different like disciplines to
work together,
into dialogue, which is really hard. And that's where when you're really trying to understand what the other person is saying, that's where the goal is mine. It takes time.
Maybe we can pick this up and discuss. So, okay, obviously you can't study token engineering. There are some relevant backgrounds also mentioned, already mentioned, but then this is a matter of working cross-disciplinary in the applied sector or in the scientific sector, which is difficult today. And now there are a range of groups working in cryptoeconomics or related topics like Economic Space Agency are trying to take a different route. Maybe you can tell us a little bit more how that works in your project.
It's not easy. Let's start like that. But that's like from the beginning we've tried to really assemble the team from that perspective. Because we know that we need some economic imagination, some financial imagination to really rethink the economic component of the crypto economy.
Can you introduce Economic Space Agency in general for those who don't know it?
Sure. So we are
you should work on your elevator pitch.
I know. So we are a group of radical political economists, finance theorists, game theorists, artists, anthropologists, semioticians. Also, I think, and we've tried to ensemble the group in the sense that we could actually like rethink what is economy and what is economically possible. Software engineers, software architects in the group too, and yeah. Yeah, and we are in the middle of that. Have been since the 2015. We're just about to release our economic white paper called Protocols for Crypto-Economic Networks. We've been working on basically on three things. On the bottom layer is the a distributed network runtime, logically distributed network runtime. In the middle layer, there's a multi-agent network programming language and environment to program the crypto-economic networks. And then the top layer is where we'll be now working on and publishing the protocols. Is like this. It's an protocols for economic interoperability. Crypto-economic networks. We really think that we've come up with a new language for economic expression.
So the overall goal is to redefine what we value in an economy, like you put it, I think, in our last conversation.
Well, let's say to open it in a way that if we think, I mean, if you take a network perspective on economy, so economy it's a network where a group of agents are just participating according to certain shared understandings, shared communication agreements, protocols basically, and what is valued is part of these shared understandings. Then you suddenly understand that that the capitalist economics that we have now, it's a very narrow understanding of a network like this. What is valued, like have one index price, one measuring unit of profitability, like compared to the kind of data and information that we have, it's ridiculous.
Yeah, I mean, a genie kind of thing across different economies.
There, I want to make a kind of an example, I think, that simplifies the ridiculousness of the current economy. Like if you compare it to games, you'll find that games always emergently or designed to create their own values. Like the value of a certain piece for a chess player, the value of a ball in a certain position for a football player. You can go on. It's an infinite space that constantly changes even within one game. But all those have value evaluations. Like why people are angry when the ball escapes them, it's because it was what they wanted and didn't work out, and of course vice versa. But that points out that any system in itself unavoidably generates a new value scale. And it's even its own value forms. So we're talking about an infinite space. And in contrast, you could take that we're kind of children that have been living in this one game from our birth, and this game has been conditioned to us like Pavlovian jobs, like if you don't do this, you don't get food, and then you end up on the street, and then you might die. And therefore, we're kind of living in, like, economic-wise, in a similar situation than, let's say, Western Europe was at the kind of end of Middle Ages, where everything had to be explained, whether philosophy or whatnot, in terms of Christianity and particular visions of Christianity. Yes. What we're lacking is the capability of variance, which we can see in games. And while we look at system-wise economy is similarly structured, that variance could be there. It isn't because we are monotheistic.
Yeah, so Pekko is one of the game designers from our team.
Yeah.
I see. But so there, I mean, interesting argument you made. We see in the practitioner space, we see a lot of enthusiasm around questioning the values in our current system and what could be valuable in future economic systems. Let's compare it to academic sector. So you obviously decided to start an independent project. Does this rethinking economies take place in academia?
Well, from my perspective, not much. I mean, well, if you really think of the cutting edge of economics in the universities too, I mean, I think the most interesting things are in the you know, not in the mainstream, but in the like below the staircases, like the anomalies of the why things are not working how they should. There is really interesting things happening also in the research, I think, but otherwise, no.
Chris, any comments from your side? So what's your perspective on that? Chris, are you still there?
We might have lost Chris. He messaged me a few minutes ago that he was low on power.
Okay, got it. All right, any other observations on that, academia and visionary stuff around new economies?
Yeah, but then it's also, I mean, you have to, just like what I think what Michael is doing is so important is that we really need to get into experimenting and doing these things. Doing these things, but then that leads to another problem. So what's the infrastructure like? What's the organizational context that you can do it? So Michael, your approach has been a private company. We are organized in a different way. Now the new journal, I'm not quite sure what's the structure for that.
Yeah, we're not a legally distinct entity as it stands, so we're just part of the DCI for now. But this thing which
is kind of a worrying sound to me, for instance.
We'll be fine. I don't want to say too much because a lot of things haven't worked.
You don't want to say that in public.
But everything is fine. We're quite freestanding. In respect to MIT, we're one of the most independent groups that you could possibly imagine inside a university, talking financially here, as well as in terms of agency over our actions.
Okay.
I was going to comment too that, like, you know, block science isn't particularly conventional from a startup perspective because it's totally bootstrapped. So the reason why we're bridging academia and industry is because we fund ourselves entirely through doing projects, but we actually expend our resources building tools and trying to work with the community to generate best practices. And it's kind of a tension because it means that we are not actually following the sort of what the capitalist paradigm would demand, which is that we do the things that will make us the most money. We're doing the things that fit what we view as valuable, and then we're treating, you know, financial sustainability more like a constraint and our value system as our goals, and that value system ties back to exploring this economic design space, exploring the tool space, but it's not very well, it doesn't work well in the existing paradigm. It's got like tensions. And so,
we've been talking about this with Michael before. Kind of, it's really also about the journal. I mean, after the MIT event, if I may be frank, I was feeling that, yeah, it was a beautiful event, things were well organized, but there was some feeling was missing. Kind of the affective, emotional side was missing.
I brought you a glass of red wine. You didn't
it was a nice move, but
there were other things there. You missed it.
But what I'm saying is that, and now, okay, how the journal is going to be organized, and another kind of what like could we think that the knowledge production, research, knowledge production and its distribution could be like think of the agents involved in a think it in a
you could be much more way. You could organize it in a much more radical way.
Yes.
This is more like this is more like
copying the older model.
It's an iteration away from the existing model trying to pull the center of gravity away from it whilst maintaining interoperability and backwards compatibility, career compatibility, incentive compatibility. With
Those are like
system.
very key, I guess.
We have these many constraints that we're operating under to try and make this thing legible and credible to the previous system, which will help us bootstrap the thing so that we can iterate it further out into the dimension of all possible futures.
Is it right if I might say this? Like you're trying to build a publishing bridge between the so-called centralized paradigm to the new decentralized version?
Something like that, yeah. Something like that. And
the question, though, is whether or not, so that's a totally valid strategy in a broad sense, but one question is whether we can actually generate escape velocity, because the current institution of academics has so much what I'll call baggage, and just like it's accumulated, it has a large inertia, it has a large gravity well. And so the question is whether or not it's possible to escape that gravity well, because I don't know. I'm not saying like you can't but just that there's a real concern that an incremental approach is going to be stuck in that gravity well, no matter how hard you run.
Yeah, sure. It's a valid point. It's hard to know. I mean, like we don't know this.
Yeah, there's even horizon there.
This possibility space is not known to us.
Yeah.
So I've got friends that want to do, and colleagues that want to do much more radical decentralized publishing projects, but they won't be able to rely on the resources and reputation from an existing institution to bootstrap that, to appear credible, to appear legible to a existing body of researchers. So there's different. It's a trade-off. It's a trade-off, right?
Well, for those of us who are already in what I'm going to call academic no man's land, I'm basically looking at this as I'm submitting a paper to the journal. I've been working very hard on it with Sherman. I'm looking at publishing some things in the upcoming cycle for my previous discipline. So like Conference on Decision and Control to me is a really good place to go with some of the more mathematically advanced work, because they already have some space for discussion of social systems, and they have a journal on the control of network systems in that community. So like I'm looking at actually reintroducing myself to a place where I've previously published on things like, resource allocation to prevent pandemics and dynamic optimization problems that actually share a lot of mathematical character. But at the same time, I have to fight against the gap in my publishing history. And so I'm looking at that. But then on the other extreme, I'm also publishing open source software, and I'm publishing Medium articles periodically. And so there's actually, it's an opportunity cost, but we're kind of spanning the gamut and maybe hedging a little bit to say like, look, we don't actually know which one of these things is going to be the right one, and dealing with them sort of in a portfolio. And obviously there's a cost because you're spread thinner, but you've maybe hedged against which one's actually going to help push things forward. And maybe they all will, just with different audiences.
Absolutely.
We have a question from the audience.
I was just going to kind of interject the citation practices are an incredibly powerful mechanism for building legitimacy, and something that traditional institutions can be proactive in citing alternative sources, and kind of part of the structural problems that institutions have is the kind of nepotism in how they cite other work. So I think this is one strategy that we could use.
Self-citing.
Yeah, absolutely.
And I think this kind of mirrors the underlying problem of kind of building legitimacy outside of the institution. So these are maybe ways that we can work between traditional institutions and alternative institutions.
Okay, great. You're the citations expert. I have a question for you. The question is, so imagine that you're writing a paper, or I'm writing a paper, and you're going to review it. And there's two citations. One of them is about a paper that I absolutely love, and the other paper is a pile of shit. But I cite them both, and to citation indexes, they just count as one. They count the same. So context is completely lost in this kind of web of citations. And I don't know how to do that.
Yeah.
I mean, it's pretty much a game of optimization for impact, right? So if you want to be, now that's what I was about to say to Zarkam. It's like, what is this optimization? Is this optimization to become a professor? Then he should probably optimize on impact.
Sure,
right?
what's the goal?
You can be a little bit more creative with the indexes.
Yeah, of course. So there's plenty of ways. The problem with the indexes is you always come back to Goodhart's law. It becomes a metric, and then people learn how to game it and optimize it. The question we have for Zargham really is, what are your goals for releasing these papers?
My goal is ideas moving, which means that I'm not actually doing it for impact factor, and by spreading it across these different sort of paradigms, I'm increasing the probability that the seeds grow somewhere without knowing which ones are right.
Index 2.
Yeah.
And high five.
Yes.
Got the same boat.
Okay. Maybe, Wassim, this is the right moment to talk about another idea, which is peer-to-peer review.
Yes, this is an idea we've been pushing around for a few months with relation to the journal, and some other people have brought it up under a different guise or a different name. So I call it peer-to-peer review. Other people call it mercenary peer review. And the idea basically being, in a nutshell, that in this space of cryptocurrency and blockchains and cryptoeconomics and token engineering, everything happens upside down and back to front compared to traditional academic fields. So think about, it all started with Nakamoto 2008. It's like a paper uploaded to a random server by somebody that disappeared. So there's no like IRL reputation to this person. This paper did not go through the kind of, let's say, the human verification of peer review. And later on, there were some mathematical researchers, some dynamical systems researchers, Perez, Marco, and Grunspan, among others, that found some errors in the mathematical relationships to the likelihoods of blocks being found. The probability distributions, a simplifying case was presented in the paper, whereas the true case was more nuanced. Those are the sorts of things, I mean, that might sound like quite a small thing, but you think about the countless billions of dollars that have been invested into proof.
I mean, even Merkle tree, the way it was,
sure,
like very, very,
leaf node,
absolutely, like a lot of things, like
things just fall through the cracks.
Absolutely, this is why I was describing, like, when you actually do this, like, peer review, and there's existing models available, like, if you could get hold of it and use it, that'll be useful.
Okay, yes, so we have to wear out Anish before we can finish. So the idea is to reopen the historical archives, to say that it's open season. You can take any paper from anywhere in history. It doesn't have to be, start at Nakamoto. We can go back to Lamport and a Byzantine fault-tolerant consensus. We can go back to Shannon and information theory. We can go wherever we want. And we can look at these things through the lens of today. We've built this extensive interdisciplinary review committee, people from law and social sciences and cryptography and protocol engineering, everywhere in between. Imagine putting 5 of these people from different fields onto one of these old papers. Think about, like, I don't know, a Mimblewimble protocol paper, the Ethereum yellow paper, Nakamoto. So send me suggestions for papers that we can peer review. That's what I want.
But does it need to be a committee?
Doesn't necessarily need to be a committee. The idea being that the different people from different perspectives will take a different stand and also think about in these terms. If there's a division of labor as well with specialization, so that you wouldn't necessarily need to review the whole paper in a wide and shallow way. You can focus instead on that one particular section which your expertise speaks to, or which you've identified a discrepancy in.
So I'd like to make a point about interdisciplinary, whether it's reviewing or just discussing things in other fields. What I find is really, really important to sort of cross-disciplinary learning and even cross-disciplinary, either criticism or support is a sort of fundamental understanding of epistemology, and not just in this sort of purely, one-dimensional sense, like this is the right way to think about how we know what we know, but actually to understand that epistemology itself is multifaceted. So one has to sort of judge the way in which people make arguments rather than whether or not you agree with the arguments. And I think this is really important because I see a lot of criticism where people come at things because it's not the way they would have done it, rather than actually looking at whether the thing that was done makes sense in its own sort of lens. And it doesn't mean it's right or wrong, but there's a question of like, okay, is this a experiment? These computational experiments. What is the sort of appropriate methodology and inference from computational experiments? Are these a sort of first principle logical construction? Is this a math proof? Is this there's a wide range, and I'm just, biased towards my own areas of knowledge. But whenever you actually examine something that's not in your immediate domain, I feel like you have to have an understanding of what is appropriate for that context. And without some understanding of epistemology at a base level, it can be really easy to sort of bash on something without understanding that it was actually very well done in its own context.
So this is a remark on the how of this review. One question on the what. So you said we can go back to any historical papers, but would it be also possible, you said you're missing skepticism in the blockchain space. Would it be
That's understatement.
Would it be possible to hand in, let's say, papers from the applied sector blockchain projects to get the comments from the academic field?
Like case studies.
Yeah.
Correct.
So there are some journals that look at case studies. There's that, what's it called now? Journal of the British Blockchain Association, where if you have a problem, the answer is blockchain. I think that's basically, you don't need to read the journal now, like blockchain is the answer. And so I've heard from some professors that those case studies are quite useful teaching aids. They can illustrate how you might use a blockchain-based system in practice. But I don't know if it would...
the level of skepticism I'm referring to is not what you're referring to. What I mean by that is imagine, you just described Nakamoto's paper, right? You were saying the $1 billion thing, right? What would be interesting is imagine you are building $1 billion thing. Would you actually apply this amount of rigor in a traditional world, still traditional financial world, and equivalence of that rigor onto whatever that's existing in a normal blockchain world? That's, to me, is a simple finger in the air kind of estimate. Does that make sense? Yeah.
So I have a question too about the sort of the Nakamoto white paper and sort of separate review. I'm not an expert at the sort of cryptographic peer-to-peer protocol level, but I have a friend who many of you know who's a peer-to-peer systems researcher. Her name is Shebnem, and she worked at Siemens at the time that the Bitcoin white paper came out. And her comment is always, I read it and they did, X, Y, and Z in ways that no, peer-to-peer networking person would ever do. Therefore, I put it away and forgot about it for X years until it became a big thing. And I went, what did I miss? And one of the questions there is this expertise bias, which is okay, maybe something really innovative happened at the same time that something that an academic would call a no-no or a researcher would call a no-no was also present. And I feel like there's a little bit of this sort of expertise bias happening in a lot of places where so much about this one thing that you're the super expert on or whatever. And as a result, when that thing isn't, quote, right in the way that would check a box, you discount the whole thing. And I know this discussion kind of reminds me of that. And I wonder if anybody else has any thoughts about places where they might have dispensed with something because it violated something they knew to be right, but yet somehow still turned out to be, big and impactful and meaningful.
Yeah, let me just quickly speak about Bitcoin, then we can broaden it a bit. So the general consensus that I've come through, I'm still quite a member of the Bitcoin community. In fact, I was talking with Adam Back, who cited in the white paper the other day about some interesting names of people who he thinks might have been around in the years before Bitcoin's network launched. But there's this saying, which is perfect is the enemy of good. And there's another saying, which is Bitcoin is worse is better. So Bitcoin has a lot of kludgy solutions to things. So the ECDSA was not the best choice. You could have sworn was off patent, but the implementation that was mature was ECDSA. There's a lot of things like that.
Design choices.
Design choices, yeah. Basic random parameters, 10-minute blocks, 1 megabyte size, the asymptotic halving, the difficulty targeting. But putting these things together was a non-obvious thing. And I think the reason it escaped a lot of academics, or it seems like it wasn't an interesting thing for academics to look at, is because for a hyper-specialized person, they'll probably see, oh, that's a bad cryptographer. Oh, that's a bad peer-to-peer networking person. Oh, that's terrible economics. But if you put it together, you've got this thing. I mean, sure, it's still set together with string and duct tape, but it still seems to work. Yeah.
But you are saying, Michael, maybe those ideas would have got killed in any review, scientific review.
Yeah, that's actually what I'm saying, is that if it had been reviewed by experts in those domains, that it would have gotten shot down, which is, I mean, maybe it's a feature, maybe it's a bug, I don't know. I'm just saying that, based on what Wassim described in the sort of, explanations that I've had from my, colleague who's a peer-to-peer systems expert, that this is a real risk of whether it's stifling innovation or is it improving the quality of the design. I mean, that's up to your opinion, right?
All right. Are there any questions from the audience?
I think the blockchain space and the crypto space has really moved into a kind of open source first, open publishing first paradigm, which is kind of on the whole an incredibly good thing. I think there is potentially still a valuable role for private disclosure, particularly when there's financial interests at stake. So I'm wondering, particularly in the peer review case, what are strategies, venues for this kind of disclosure that you think we can make more robust? Just a more concrete example, if you are in the Ethereum community, there's a large financial interest in, and potentially you're associated with an organization that's developing a product. There's, you have vested interest and reputational risk at play when you're criticizing maybe components that are kind of interrelated to your stack, but these could be invaluable resources for the protocol and community at large. So how do we kind of approach that and build legitimacy around this kind of this disclosure method? Yeah.
It's difficult. I'll start. Yeah, it's really difficult. We're actually having these discussions at the moment regarding the journal. So the traditional, we started with how computer science usually does it, because in computer science we do have a tradition of things spin out of universities. There's some tech, it gets developed, then a startup is made, or it's sold and it goes into the world. And so there are conflict of interest guidelines, very standard ones in computer science, but they're mainly to do with academic interrelationships. So for example, if Anish was my professor when I did my PhD, then for a certain amount of time, I would have to declare that there was a conflict of interest should I be a reviewer and he have a paper that's under submission. This thing gets more complicated when people are printing money out for that. That is very true. And so we're still trying to work out how to do this. If you make it too, if you design it in a clumsy way, it will be a tremendous disincentive for anybody to share anything. Yeah. And that's the thing you have to avoid. Or you're then tying you're making people into targets. If you say, if you own more than $100,000 worth of a cryptocurrency, you have to tell us. And then there's this target on your head next time there's a bull run. I know whose car I have to jack.
Yeah, and there might be mechanisms that you could have to actually have selective disclosure, blind disclosure, things like that. But what you pointed out is absolutely true. I mean, I've been watching the ecosystem, and at times I play with it, so I know the impact of making any such disclosure to most of the people. Significant economic impact, so there is no incentive for them to ever do that. So it's what's going to be the loss? It's a question, right? And mostly the whole game is optimized for short term, not the long term. And the overall situation will be the tragedy of commons for everybody involved in this ecosystem. And I don't see there's an easy solution for that.
It's very difficult. One of the things that we're trying to do, so the way that peer review tends to work in academic journals at the moment, is that you have this thing that's called a double or triple blind review. The idea being that the authors remove their name from the paper before it goes into submission. And then the reviewers are not known to the author's not known to the reviewer, and the reviewers are not known to each other. What we're trying to do, what we'd like to do, is, because one of the problems with this is, that the people that are doing the reviewing, their reports are never seen. They just kind of drift off into the ether and they're never seen. So if somebody has like some valid criticisms of something, some mistakes, that could get buried and we may never see it. So what we want to do is we want to do an open variant of peer review, where the reviews will be published afterwards with optional review of attribution. So imagine, you know, Exceli wrote a review of a crypto system and he found an economic flaw in it. But if he put his name on it, then he would suffer tremendous negative consequences. So then he would decide on that case whether he would sign that review with his name or not. And so that's one of the ways we're trying to ameliorate this situation, but it's very difficult. And you can't be sure that people are going to tell you things either.
Yeah, but it would be interesting to experiment, iterate, play a little bit.
We have another question.
I'm devil's advocate, but I know professors who know by just seeing the comment.
Of course, it's a small world.
Small enough.
Small world.
Yeah, exactly. So,
look, I submitted a paper today to a conference. I didn't even anonymize my paper because I'm like, they know who I am. So I just send it. So, but it's not a perfect system. But it comes back to this, what's the saying? Democracy is the worst form of governance apart from all the others. It seems that peer review is the worst form of verification of research apart from all the others. So if anyone has any replacements for peer review, please come see me now.
I have a thought too. I know it's a little bit tangential, but like the thing about research is that reviewing is often treated as somewhat antagonistic. And I know we're talking about relatively antagonistic reference cases, but you know, in a process of like standard sort of development of research, your reviewers are, you know, theoretically going to help you a lot. That you need those perspectives and you need the feedback. And one of the downsides is that we have sort of turned this into a competitive game when in most cases it could be viewed more as a collaborative game. And the example would be like, you know, in open source software development, and in particular, there's a cool project that you should read up on called SourceCred, where you have an attribution network for all of the roles in sort of a open source development effort, and actually even some of the discussion elements around what to develop. And in that system, you know, a review is a first-class contribution. If you do a code review, you know, you're not like attacking the person who wrote the code, you actually are servicing them. And so I think there's a degree to which there's a mental flip that, you know, switch we can flip, where at least in some cases, we can treat reviewers like first-class contributors, not at the sense of the level of author, but maybe at the level of a citation, where who were the reviewers that enabled this? And it's one thing to give them the opportunity to consent to do that by saying like, hey, I want to be included or not included. But there's, I think, a lot to be gained from viewing reviewers as people who are helping, and that they sort of share a stake in the success by, you know, helping you get it right and then getting some attribution for that, as opposed to being hidden in the darkness and therefore they become more antagonistic than if they're viewed as a, you know, a contribution that's getting some credit for the success of that thing.
Sure, as long as the incentives can stay aligned, however those incentives are architected. And so that brings us on to one of the other things that we've been looking at, which we haven't moved forwards with as yet. But for example, there was a talk at the Crypto Economic Systems Summit, and they're all online on YouTube now. There's a talk by Jason Teutsch, who's been working on a project called a token journal. The idea being that there may be a way that you can tokenize reputation in a slightly less naive way than normal. I'll admit that. Some people still gag over
reputation systems have been researched for a very long time.
I know.
They will laugh at you the moment you say that.
If you do it it's a non-financial system. So, for example, if you review, you get a token. You can use those tokens to upvote a paper for expedited review. You can't transfer or sell these tokens. They're tied to your identity. So this is a very limited reputation system. There may be a way that you can build some non-financial incentives, because a lot of the way the journals, research, and peer review works, it's not on money necessarily. It's on this academic notion of a scholarly notion of service. You're helping the ecosystem and the community by fact-checking, by doing this don't trust, verify, applied to research. And so if there's other non-financial ways that you can help people out in return for their service, then that might help to keep the incentives aligned so that we don't end up in a situation where professors are tearing strips off each other because they're fighting for the same prizes.
So I've actually thought about this a lot because obviously I think way too much about these things. But one thing I think is really important to note, that reputation is like a low dimensional operator that's sort of locally defined. Like my opinion of you is different from maybe Anish's opinion of you and like everyone else, but it's actually derived from a sort of substrate of facts, some observations that I've made, things I know about your research, maybe we've had conversations, and in a tokenized world, what you're really saying is that the provenance of all of your contributions of your service is this like high dimensional substrate, and that there's a notion that I could impose a notion of like a low level or like one dimensional metric of reputation on you and like, you know, get a rating, but that rating is so far from unique. Everyone might have a different system of ratings.
Right? It's a basic start. So effectively what you're describing is like what the collaboration oriented architecture guys have. You have interaction between two sets of parties, you bootstrap with one level, and then the interaction is over, you update the states, right? And you can actually state the end state of this, and then you can derive next stage for those people for other things.
So a context-dependent, low-dimensional measure over a high-dimensional space of cryptographically secured facts.
Yes.
Mm-hmm.
Yeah, that makes sense. I mean, that seems to me like the only thing that could make sense.
Yes.
Mm-hmm. But as long as you own it as a dimensional reduction, it only makes sense if you are honest about that. If you try to posit it as some kind of all singing, all dancing proxy and the answer to all your problems, as most reputation systems.
Right, but that's the problem that we're all calling out here. I mean, there's a bunch of mathematicians in this conversation. So the reality is that we're relatively comfortable with the idea that there's this high dimensional space that we can't totally grok, and that we're gonna, try to keep that in a really secure way, and that there's rules about when and what gets added to that high complex data structure of all the things that you've done to service this community, and that the notion of reputation is just literally a context-dependent, low-dimensional measure on it, which isn't an all-seeing eye, because you might have a different one tomorrow because some new information came to you about what's important or not important, what not. But I think this is where we get to token engineering as something that's important. We actually need to take that knowledge that maybe a handful of us now all get because we've been working in the space, and actually turn it into some sort of industry knowledge that prevents us from naively in implementing things that are actually going to create potential social system problems, because we're not recognizing that ontologically we can't have a God's eye. We have to have a context-dependent measure. And so how do we take that understanding and embed it in a best practice, or embed it in some sort of industry or discipline knowledge?
Did you just volunteer to build me a reputation system, Zargam?
No. I mean, I sell services, right? I have a company. We could really use some,
This was just an example how to token engineer the reputation system and reinvent reviews. Perfect. Thank you very much.
That's one for the next hackathon.
Yeah, exactly. Yeah. But to sum this up, Wassim, for example, how do you see, since you are taking your time in, or investing your time in finding new ways to have reviews, to have a new conference, a new journal, where do you see this academic, applied sector collaboration in 5 years? What would be the ideal?
The ideal is that we can successfully bring these people together. And also you have to remember that there's a lot of structural problems in universities, which means that they're, let's just say the universities are reorganizing, and that's a matter of fact. So if we can create links and create centers of excellence and institutions like in Vienna, then it's possible that this reorganization can work in the favor of highly interdisciplinary and collaborative activities. So that's my goal. But
are you not worried that this could become a new way of gatekeeping? So what I have observed over the years over everything that happens, look, I'll give you a very good example. Look at medicine. Why do you think people, I'm fully called a medical doctor, put my hand up, I'm fully, I say what I think in that sense. Like, what do you think those guys make more money? They control supply and demand, right? And what do you normally see in most academic institutions is some mechanism by which they supply demand and supply. So I really don't agree or sign up to things where I see society giving
Coins.
Yes.
Coins.
Yeah, pretty much. Yes, that's what it is.
But I think the gatekeeping function of academia, I think that the horse has already left the stable. That's why this reorganization is happening. It's because we don't need guardians of the knowledge, keepers of the knowledge anymore. Instead, what we need are curators and stewards.
Yeah.
And
so let's make sure that we can also, the capture of the value can be shared. We can share the risk and the upside.
Risking together, exciting.
Yeah.
Yeah.
Michael, any additions? Cryptoeconomics Research Lab in Vienna, what would be the ideal situation in 5 years?
Well, I mean, I think the ideal situation in 5 years for Vienna would be, I so can't totally speak for Sherman, but I see it as something where, something where there's it's breaking up.
Okay.
Sorry, I'm getting feedback. Oh, there we go. A situation where we have sort of built out a research community that is able to both take on things that wouldn't normally be sort of admissible in a purely disciplinary setting, and that there's an opportunity to sort of grow interdisciplinary researchers from like through their PhDs and into essentially into industry and into other academic institutions. Or I guess the best way to put it is that this institute lives in a sort of the same kind of no man's land that I think my company lives in at times, which is the bridge space that doesn't have strong support. And I think that in 5 years it could have strong support, not in the sense that not even necessarily talking financial support. I'm talking about like this legitimacy that comes from being able to build bridges into, what are the tethers to the existing system, how to get respected works into journals and get review from experts to help refine those ideas, at the same time as not collapsing into the black hole of only doing the things that academia currently values and calls for. So maybe I can imagine it as sort of being in a wide orbit around academia that allows it to explore new space while still benefiting from the benefits that there are to get from what exists today. So maybe a little farther away from the event horizon than the MIT effort, but nonetheless not completely untethered.
Okay, exciting.
Yeah, no, I'm that direction, but I would like to see in 5 years, totally doable, like a new school of economics, new discourse on economics. Like, I don't care where the actors come, academic or whatever, but that this community would be like working together, contributing, and also that the community would risk together in the production of this knowledge and also share the upside of this knowledge.
I have a question about this, because this is actually kind of one of the biggest challenges I have is when we say share the upside. I think the biggest issue I see is that the upsides are they're not inherently financial. The value system that calls for this calls for knowledge production, and knowledge production creates a massive upside and we all share in it. But actually the issue is that unless that knowledge upside is in some ways embraced even more broadly, we run into the challenge of sort of, I guess, production of a public good without a benefactor to support it. And so we
would need a language with which we could express something like that a little bit better. I think
that makes sense. I think that's the practical challenge that I'm facing when I talk about my wide outer orbit, is to get far enough away to explore new space, but to be like able to make it sustainable, despite the fact that we're not going to in 5 years see an alternative. Such a shift in the economic paradigm that we're going to miraculously have people running around saying, oh, wow, you're creating this wonderful new knowledge. Here's all the funding you need to keep your team paid and your research going.
But nevertheless, I think this questioning the economic systems of today is quite prominent today, right? So you see it everywhere, not only in the blockchain sphere.
Yeah, I mean, if you really think about it seriously, look at the situation since the I mean, since the 2007 and 8 financial crisis, if you look at the central banks, for instance, I mean, they are looking fragile. They are entering into a game where they should not have been entering in the first place. They have like you look at the volatility of the bond prices. You look at negative interest rates.
Mhm.
I mean, this is a world where suddenly the state and the kind of a credit money associated with it, it's looking very questionable. This is the situation where we are now. At the moment, at the same time, when suddenly there's a possibility through the technological development that something else could perhaps start to happen, but it should not be so. We should not stop here where we are now.
At the risk of contradicting myself, I mean, the question is, what are the characteristic timescales of shifts? Because, I said I don't expect that to be wholly different in 5 years, but I could honestly say that, as a systems person, there are times when systems actually go through sharp phase shifts, and maybe I don't have enough of a sense of what the characteristic timescale of an economic shift looks like.
Well, it depends on the environment and the conditions and what there is to like we can talk in a Kuhnian sense about paradigm shifts and so on. But if the existing paradigm is unfit for purpose and there exists a potential replacement, then we may be able to see very fast transformations. They may not be smooth.
Yeah, I mean, this is a question, right? This
hasn't existed
yet. Yeah, there's a question is like, what is the transition going to happen? What's the price we're going to pay for that? That's like probably the biggest question that we probably have to think about.
I mean,
is it a complete failure of the system, or is that going to be a transition?
Transition would be my bet.
Okay.
But when I look at the capitalist institutions, for instance, they are anxious. If they would have a possibility to short,
yeah, oh, absolutely, they would do it straight away. Yeah. I mean, it's an inversion of the yield curve that's kind of giving you a telltale sign of what is happening.
Exactly.
So, what I'm worried about is more along the lines of, okay.
But it's not the
it is like, okay, what would be the transition mechanism? From where we are right now to the new system that's evolving, there's a massive difference, 4, 5, 6 orders of magnitude difference in the mechanism sizes which are operating. And when this transition happens, it is going to be messy. Completely messy. Look at what happened when socialism as an economic mechanism worked and what was the human cost. So I am asking this obvious stupid question of like, what we as a collective think the social cost would be, and how much do you think people will pay? I don't know. I honestly don't know.
Well, the people won't have a choice what the price they'll pay will be. Why don't we look at Aadhaar?
Okay.
Look at Aadhaar, the identity system in India, which they seem to have made every mistake implementing it you could possibly make.
They're going to pay the price though. Yeah. They are paying the price already. If you haven't actually looked at it, I haven't looked at it. I can tell you very clearly that it's completely and utterly interesting. And so many people have actually said so many things about it. And the people who have publicly said things have had difficulties, right? So it's an unfortunate situation where, there's massive centralization. And in a way, it is very possible that as an infrastructure, it could be a very tricky spot for, collecting all the information. So the total amount of information you can collect on citizens, 1 billion or 1.2 billion citizens, is centralized. And that data has a massive half-life. If something happens, an adversarial action, data stays the same.
Half-life is the magic word. Data is not the new oil, it's the new uranium.
He's talking about critical mass and things of that sort. But,
Well, actually, if you don't mind, I actually really dislike the data is the oil analogy, though sometimes it's helpful. I think one thing that people
uranium.
No, I know. But what I was going to say is that one thing that's often overlooked is that data is much more of a flow than it is a stock. So, it's momentary, and I realize that people stockpile it.
That's been described by half-life.
Yeah, but that's kind of why I brought it up, because the transition from oil to uranium includes this notion of its transience. But I also, although I don't think we should go down this big rabbit hole, I do think think that there's a really important layer of discussion around data governance, which is different from network governance, that has to do with who can see what, under what circumstances, how to unbundle the rights that we associate with the concept of ownership in the context of things that are digital. There's like an entire web of relatively complex concepts that we've historically bundled in specific ways in the physical world that don't bundle so nicely in the same way in the digital world. And it's forcing us to do new kinds of research just about what does it mean to produce a piece of data, to own it, to have the right to mutate it, to have the right to see it, to have the right to delete it, etc. And a lot of these things are only just really hitting the surface.
Yes, but I mean, talking about data economy would be an entire new session where we can spend an entire night. Maybe we will do this in the future. I think you say, what is the cost of transition? On the other hand, we have to admit cryptoeconomics at the moment wouldn't have to offer that much. Transition to where to? So hopefully we'll make progress in the next 5 years in that respect too. Thank you very much for coming tonight. Thank you for this discussion. I hope you enjoyed it. Thank you for coming from the audience, and see you next time at Token Engineering meetups. Thank you. If you have any questions related to that, don't hesitate to drop us a line, direct message via Twitter, or join the Telegram channel, and let's stay in touch. Thank you.